Here we go. Happy Monday and happy new section. So we will be working on area of two-dimensional figures, and the first figure that we're going to deal with is the circle. So we know that circles information can be given to us as a radius, where we're given the radius of the circle or the diameter. So both of these have equivalent radius and diameters. Diameter would go from a chord on each side going through the middle of the circle, and a radius goes from the center out to the edge of the circle, out to a chord. Not a chord, because a chord goes from side to side, so radii. Our formula is A equals pi r squared, something we need to know about pi. Pi, we can see it as a decimal form, approximately 3.14, or we can see it as a fraction, which is approximately 22 over 7. If we look at our calculator and do 22 divided by 7, we get that number, 3.142857. If we do the pi value here, we get 3.141592. So this is the this is pi to however many degrees, however many decimal places. So understand that both the decimal form here and the fractional form are approximations, and we'll use them either way. Typically we use the fraction when the radius is a multiple of 7, because it'll cancel that denominator, that 7 in the denominator. Otherwise, any whole number, any decimal, we typically use 3.14. So let's take a peek here. So in this example, sorry about that, we have pi. We're going to write 3.14 as our pi value, and then we have radius squared. So the radius in this instance is 8 centimeters, and notice the square is outside of those parentheses because the base of that exponent here is r. So we're going to do r twice, times itself twice. Now if we look at the diameter, we know that the diameter is twice, so we would just divide by 2, which would give us our radius. So the diameter is twice the radius. So we're always using, the only formula we would ever use is radius. You would never use diameter when doing the area of a circle. We would have to find out the radius. It only works with radius. So if you're given the diameter, you have to find the radius. So we plug in 8 centimeters. Remember, we can distribute that, and there are two terms here. We have 8, and then we have its unit. So 8 squared is 64. Centimeters squared is centimeters squared. So notice the difference. The exponent is outside. Now the exponent is inside. And there's parentheses because it's showing multiplication to the 3.14. So then we take 3.14, we multiply it by 64, we get 200.96, and then centimeters squared. So I write equal, that's also an approximation, but we don't have to get technical about that. You can write the equal sign. We understand that it is an approximate value. So what I would like you to do is I'd like you to try for this one. Find the area of that circle. Pause the video. Write down your work in your notebook. You should be keeping track of your work, and so we can transfer it onto the exit page, and we can refer back to it when we are preparing for the pre-assessment. So pause it. When you're ready, push play. So here's our answer. Pi, we're going to plug in 3.14. You notice that we're given the diameter, so we'll take half of that in order to get the radius, which is 4.8 inches. We're going to plug that in for the radius. We're going to square that. 4.8 squared is 23.04. That doesn't seem right. That doesn't seem right at all. Hold on. Let's see that. 4.8 squared. 23.04. Oh, 64. Yeah, I don't know why I didn't. Yeah, that worked. Sorry, my bad, Mr. Mac. But not a bad thing to check. And then inches squared gives us inches squared. Then we multiply 3.14 times 23.04, we get 72.345 inches squared. Notice it doesn't say to round, so we would just give our answer all the way to the tens, hundred, thousandths place. We would not round. It did not ask us to round. The next figure is a triangle. Triangles will come in different shapes, but let's look at the formula. The formula is area equals base times height divided by 2. Something we always need to remember is the height must be perpendicular to the base. So if we have this as our base on our first one, the height must be perpendicular to that base, which that height would be on the interior typically. You might even see it on the exterior like this bottom one. But and then if we're given a right triangle, we're understanding that this is a right, that is perpendicular, and that would be perpendicular. So in the second figure, that's more of a typical one, and then the third one's the tricky one, where the height is outside of the figure. That's the base. It needed to be from the base to the top of the figure is always going to be the height. From the base to the top of the figure is always going to be the height. From the base to the top of the figure is always going to be the height. So we have that. They always need to be perpendicular. So let's, did we not try one? No, we didn't. So you try. So see if you can find the base and then the height that is perpendicular to that base. Pause it when you're ready, unpause it, and we can work on the answer. So in this example, we're going to use this as my base. Typically, a lot of people want to use this, but the only problem is we don't have a perpendicular height, meaning it has to be perpendicular to this base, to the yellow, and it has to go to the top of the object. So there is no height that we have. There is no measurement. That's not that line. That's not that line. So we can't use that 11 feet as our base. What we have to do is look at another figure. So if we use this as our base, do we have a perpendicular line to the top of the object? Yes, we do. So let's do this. If I turn this way, notice now that my height, my base is here, and this would be my height, perpendicular to the top of the object. So that's a fun, nice, tricky problem. So we're going to use that as our measures. So this will be our base, 10, and this 9.2 will be our height. So we'll plug that in for base and height, and our units are feet. So 10 times 9.2 gives me 92 feet times feet. So notice that I'm still multiplying the two units to give me feet squared. And then we divide it by 2. 92 divided by 2 is 46. So my answer would be 46 feet squared. Next object is going to be a square. This is relatively simple. We know that in a square, all sides are the same or congruent. And we also know that all of the angles are 90. So if one side is 3 meters, we know that all four sides will be 3 meters. So our formula, not a lot of people think that the formula for a square is base times height, which it can be because a square is a rectangle. But a square, the real formula is s squared, meaning you're going to square a side. And that makes sense because your base times your height would just give us s squared. So 3 meters squared, we're going to square the 3, we're going to square the meters, and we get 9 meters squared. Take a moment, try this one, writing down your work, and then when you're ready, unpause the video. We have our side length is 3.2 yards. So we're going to square 3.2, which gives us 10.24, and we're going to square yards, which gives us yards squared. Next figure is the rectangle that we had talked about. Rectangles, again, we have base times height. We know that the height must be perpendicular to the base, and that goes from the bottom to the top of the figure. So we see that our base and then our height goes from the base to the top of the figure. So our area is base times height. In this example, our base is going to be 10 meters and our height is going to be 3 meters. And we multiply 10 times 3, which is 30, and meters times meters, which gives us meters squared. Try this one. Pause your video. When you're ready, unpause it. So we have a base of 10 centimeters and a height of 9 centimeters. 11, did I say 10? 11 centimeters. 11 times 9 is 99. Centimeters times centimeters is centimeters squared. Now the parallelogram, again, we come into this base times height. Base times height still needs to be perpendicular to the base, and it goes from the bottom of the object to the top is going to be the height. Not this line. This line is not the height because it's not perpendicular. It doesn't measure perpendicular from the bottom to the top. It definitely has a distance from the bottom to the top. It's just not perpendicular. So you try this one. Pause the video. When you're ready, unpause it. So our base is going to be 5 meters, 5 miles. That's a long base. And then our height, which is perpendicular to the base that goes from the bottom to the top of the object, would be 2 miles. So we have base times height, and our base 5 miles times our height 2 miles would give us 5 times 2 is 10, and miles times miles is miles squared. The last one is a trapezoid. Not a lot of people are familiar with trapezoids as much as I'd like them to be. You again have a height and you have bases, but this time it's really, you could look at it as the average of the bases because we're going to divide it by 2. So if you add 2 things and divide it by 2, that is sort of understood that we're taking the average of those 2 bases and then multiplying it by the height. So one thing that we need to remember is our bases must be parallel. So if these are my 2 bases, if this is base 1 and base 2, they have to be parallel to each other. So the formula is area equals 1/2 height times the quantity b sub 1 plus b sub 2. And that just means base 1 and base 2. So we're going to plug those values in first. Our height is 3.5 kilometers. One of our bases is 3.7 kilometers, and our other base is 9.9 kilometers. In orders of operations, this is not a parenthesis. That is not a grouping symbol. That's just showing multiplication. So we would have to do what's inside these parentheses. We have to add those 2 together. You get 13.6 kilometers. You're going to multiply that by 3.5 kilometers. 3.5 times 13.6 gives us 47.6. And because we're multiplying, we're going to get kilometers squared because we're multiplying kilometers times kilometers. Notice we didn't get kilometers squared here when we add, we're just combining their coefficients. So we don't have to do that. So we're just combining like terms here. We're going to combine their coefficients and keep the unit. But in this one, we're multiplying. So when we multiply, it's going to give us that squared value. And then we have to take half of 47.6 kilometers squared, and half of 47.6 gives us 23.8 kilometers squared. Here's the last one. You try this one. This is a trapezoid, and take a peek and unpause it when you're ready to see the solution. So we have our formula. Area equals 1/2 the height times the quantity b sub 1 plus b sub 2. We have our height, which is going to be 9.7 because it's perpendicular to this base. This is one base. It's also perpendicular to that base. So those are my b sub 1 and b sub 2. It doesn't matter if you plugged 4.1 in for b sub 1 or if you plugged in 11.9 for b sub 1. It doesn't matter. They are interchangeable, but 4.1 meters plus 11.9 meters gives me 16 meters, not meters squared, 16 meters. And then I'm going to multiply it by my height. And now we're multiplying meters times meters, which gives us meters squared. 9.7 times 16 gives me 155.2. And then we're going to take half of that value. And our answer is 77.6 meters squared. Always remember to have units. If you do not include your units in your final answer, it will be important and you will be marked off if you don't have the units. One last trapezoid that I want to show you is this trapezoid. This is a common trapezoid that a lot of people mix up. If we have 5, 2, 8, and 11. Here's a question. What are your two bases? Think to yourself. Is it 5 and 2? Is it 11 and 8? What are your two bases? Your two bases in this example is going to be 5 and 2. They are the parallel ones. 8 and 11 are not parallel. So those are your bases. All right, and what is your height going to be? Is it going to be 8 or 11? Well, it's going to be 8. It's going to be 8 because it has to be perpendicular. So because this is perpendicular to this leg, that makes it the height. Good luck. Come and see me during office hours if you have questions. And good luck this week. I look forward to it. It'll be some fun material.